Hey everyone, Geophysicist Stefan Burns here. Breaking news, Comet C 2025 R2 SWAN just underwent a significant outburst in activity, making it brighten quite dramatically. That was back on September 26th. It is still brighter than expected now today, September 28th. And well, today we just had a 6.4 M-class flare, the strongest solar flare in months now, going all the way back to June 19th. So solar activity certainly is ramping back up in solar cycle 25 maximum. And here's what's so interesting about all this. We had two nova explosions light up our night sky, causing there to be a wave of extremely highly vibrational X-ray and gamma ray light radiation. And then, well, just a few days later on September 26th, we get this outburst of activity from Comet C 2025 R2 SWAN. And then less than 2 days after that, from the exact same vector angle direction on the sun, we get the biggest solar flare that we've had in months, a 6.4 M-class flare that does in fact launch a coronal mass ejection out towards the SWAN comet. So that is the energy progression that has been unfolding. Two nova explosions, outbursts of activity from Comet C 2025 R2 SWAN, and then the biggest solar flare in months. And now it's pinging back in the other direction with this coronal mass ejection that will hit SWAN comet in about a few days. The SWAN comet is going to be closest on October 21st at only 0.25 astronomical units away. The same day we have that superior conjunction with interstellar object 3I Atlas. So it'll be 3I Atlas, the sun, the new moon, and then the Earth. So there's a very unusual geometry being set up for October 21st. The other interesting thing about that is that both 3I Atlas and the SWAN comet are very close to parallel to the ecliptic plane, which is the plane that all the planets and the sun are on, and that's where the solar wind flows out. You have the heliospheric current sheet. All the electromagnetic dynamics really are confined to the ecliptic plane if we're talking about the inner solar system and more. That's where the majority of action is happening. Well, they're very closely aligned to it, and on October 21st, both of those objects are going to be right in the meat of it. This coronal mass ejection will sweep by SWAN comet, and after that, we don't know what's going to happen, because look at the tail on this comet. It is more than 2.5 degrees across in the night sky. So if you are outside and you're looking at the full moon, that is 0.5 degrees for reference. So this comet is a very large structure, just at least as seen from Earth. And we see that there's often tail disconnections when you have a coronal mass ejection sweep by a comet. It can also cause the tail to ripple. And what we effectively have is this nucleus here with this comet of rock and ice and dust. And there's volatiles that are outgassing. And so you now have dust surrounding this. You have some gas surrounding it. Because there's gas and dust in space under the radiative influence of the sun and also the ionization ability of the solar wind, you now have a complex dusty plasma, called complex because it's really difficult to model. All of a sudden, plasma, once you include dust into the equation, because the dust grains take on charge, and then it discharges this plasma behind the comet. And what we see time and time again is that when comets or interstellar objects get close to the sun, they seem to trigger significant solar activity. Oumuamua back in 2017, perihelion on September 9th coincided exactly with the two strongest solar flares of a weak solar cycle. And the day before its perihelion on the 8th of September, we had the strongest earthquake of 2017, a magnitude 8.2 in Mexico. And now we're seeing these other comets flying around in our inner solar system, seemingly triggering solar activity. We just had 3I Atlas get hit by a coronal mass ejection. We're going to have the SWAN comet here get hit by coronal mass ejection in just the next few days. It's going to be really interesting to see what happens with its tail. Maybe it brightens even more dramatically as it gets closer and closer to Earth. That's the thing. It already did its perihelion, its closest approach to the sun, back on the 12th of September, but now it's going to be getting closer and closer to Earth. And so if it is forming a connection and a resonance with the sun, then anything that the sun launches out towards it will get closer and closer to the Earth as we get into the middle of October. So that's what we'll dig into in today's video, this outburst from C2025 R2 SWAN and also this 6.4 M-class flare and what we may be able to expect in the weeks ahead. In my mind, the most important thing here is the relation between all these events. And so let's go straight to our orbit viewer provided by the Sky Live for this SWAN comet. This is set for today, the 28th of September. We see the orbit of C2025 R2 SWAN right there. And we see the other planets in the inner solar system. We could even zoom out to the outer solar system too, like this. But you'll notice if I do that actually, see the orbit of the SWAN comet, it's very closely aligned to the ecliptic plane. So it's coming in very shallow and then it's going to swing back out like that. It's not this high inclination orbit, something like that. It is aligned in this ecliptic plane, interacting with the solar wind and any other things that the sun launches out during its stay in the inner solar system. And so we can go back to the 26th of September to see the position that it was in when it had its outburst. Here we have the Earth, there's the sun, here's our comet. So let's get Earth and sun aligned just like that. And you'll notice that it's about 35, 40 degrees. If we go kind of like this would be 90 degrees, of course. So it's close to 45 degrees, all right? If we go to the 28th, we effectively see the same story. It's a little bit closer now to the Earth, of course, and also that degree changed a little bit. But in general, any activity on that half of the sun is going to be significant, especially if it's kind of in that intermediate zone, not exactly on the limb, 90 degrees from the Earth, and not exactly Earth center and direct. So that's the position of the SWAN comet today. Let's look at our 131 angstrom view of the sun to see where that strongest solar flare in months occurred. And here we have our 131 angstrom view of the sun, which is really great for allowing us to see solar flares, which we have not been having many over the past few weeks. I mean, there's always solar flares occurring, but really the intensity of them has been quite low. You may have seen that flash. That was today at around 8:30 a.m. Universal Time, September 28th. This goes all the way back to the 26th. And I set it back to 26 because solar flare activity was low the first half of the day. Then it started to ramp up. You'll see activity from both sides. That big flash right there was that 6.4 M-class flare. So it's not exactly on that like perfect angle with R2 SWAN, but it's pretty darn close. So we have this zone on the sun right there releasing the biggest solar flare that we've observed in months, and it's launching a coronal mass ejection out into space, which is almost certainly going to sweep by this comet. Let's check out that coronagraph imagery. And here we have our latest coronagraph imagery for the past 24 hours. This is looking at the sun right there. They put this disk over it so it's blocked out so we can see the outflowing of solar wind and more, also like these solar storms that are launched. And this is 32 solar radii across, just FYI. Well, look right here. There is that coronal mass ejection launched from that 6.4 M-class flare. And so it's not being launched towards Earth. If you have a solar storm launched towards Earth, it kind of expands out like this on the coronagraph. It's called the full halo coronal mass ejection. You can also have partial halos where a little bit more of it is skewed towards one side. But in general, it's kind of going like this towards the Earth. When it's going off to the side, that's indicating that there's an angle to it. And that lines up exactly in time right here. We'll give this a watch. Right there lines up exactly in time with that 6.4 M-class flare, which gives us quite a bit of confidence that it is from that event. It lines up in the coronagraph, the angle, and also with the time. And it's also a bigger solar flare, which is something that you generally need, not always, but generally need for a big coronal mass ejection. Which, if you want to simplify, it's really just a big wave of plasma that the sun sends out into space. It's a coronal mass ejection because it's an ejection of mass from this solar corona, the outermost atmosphere of the sun, where there is a bunch of very highly vibrational and high temperature plasma. So this is a little bit of education lesson there for you. But this is launching out towards this SWAN comet, which already underwent an outburst in activity and is still brighter than normal. Let's look at the light curve. And here we have our latest apparent magnitude brightness observations for Comet C 2025 R2 SWAN. We see our simple fit there with that orange line, which is basically just creating that good average of all the different data points. We see that it used to not be as bright. So the higher this number, the less bright it is. And each increase by 1, going from 8 to a 7, is 2.54 times brighter. So you start to stack that up and it actually becomes quite significant pretty quickly. So down here, it's just outside of visual range. I mean, it's not that hard to pick up at the telescope at these apparent brightnesses, but you're not going to see it with your eyes. But once you start to get to this range of about 6, well, now you maybe can see it with some binoculars, especially if you have good viewing conditions. And well, look at what happened. We had basically all of our observations fit this line very nicely. It's getting brighter and brighter as it gets closer to the Earth, which makes sense. It just is perihelion. It's well within the inner solar system. It's going to be a bright comet. Well, look at the jump. All of a sudden now, going from this expected apparent magnitude of 6.5 all the way to the highest value here, which is 5.7. And today it's 5.8. So that 5.7 there was taken on the 26th. We see that right there. Now it's the 28th. It's only gone up 0.1. So it's basically staying just as bright as it was during this outburst of activity. And the timeline, again, I just find it fascinating, is that you have this comet that's close to the Earth, but also close to the sun, just in the inner solar system, undergoes an outburst, and then less than 48 hours later, you have the biggest solar flare in months, effectively exactly in line with that comet, which then launches a coronal mass ejection at that comet. How's it going to interact with that? What's that going to trigger next? That's kind of the unknown. And then the bigger story with all this is the fact that, again, it's going to be the closest to Earth when we have that very interesting superior conjunction with interstellar object 3I Atlas. This comet here is not of interstellar origin. It's flying in from deep space, but it's not at a orbital trajectory or velocity that indicates that it is of interstellar origin from, you know, maybe 10,000 light years away or something like that. But it's clearly interacting with 3I Atlas, the Earth, and the Sun to set up a bigger electrodynamic circuit around October 21st. 3I Atlas behind the Sun has this very large, complex, dusty plasma shell around it. We're calling it a coma. It's more than half the size of the Sun. It's getting bigger and bigger as it travels into the inner solar system. It was just energized by that coronal mass ejection impact on the 25th of September. We're waiting on new imagery on 3I Atlas after that impact, especially from the high-powered telescopes that we have. And, well, then this comet's getting closest to the Earth right around that time. So I expect the middle and end of October to be very dynamic with solar activity, and what we are seeing now is really just a prelude to that. But we can see how solar activity has been increasing just over the past 7 days by looking at our X-ray flux. Let's check it out. Here we have our X-ray flux as observed by the GOES satellites at 5.6 Earth radii. These are geostationary satellites, and X-ray flux is a measure of the X-ray radiation coming off of the sun. Really, it's just the X-ray radiation that we're observing in space, but the big emitter is the sun. And so we see 7 days here. You'll notice the X-class flare scale rating. So it goes from A, B, C, M, and X. X is the highest. You have an X-class flare, that's big solar activity. You'll never really get an X-class flare during solar minimum, or at least it's extremely, extremely unlikely. But you start to get to M-class flares, those are big solar flares, and then X-class flares are, of course, the big daddy. Well, we've been hanging out around the low C-class level. Back here, September 22nd, that we started to ramp up, as you can see. We've had a lot of sunspots on the sun, peaking at over 200 a few days ago, but all of them are quiet. Now again, we're about 165. Solar flux again, about 165. But activity in terms of solar flares is picking up. So see how that started to go up there? We started to get some low M-class flares. And well, this flare right there is the biggest since June 19th. That is a 6.4 M-class flare. We can zoom in on that more with our 3-day view. You really see where activity was low and then that state change that occurred. And if we go to our 1-day view, we see that even better. And we're still getting more activity. So that sunspot group 4232 is not yet Earth-centered direct. It has about probably 4 days until it gets there, and then there's kind of a time range around that. There's other sunspot groups as well. So we could be looking at some solar activity headed towards Earth in the days ahead, depending on how this sunspot group evolves and whether it continues to do flares like this. This was a fairly short duration one. Sometimes you get these really long duration solar flares. Those are ones that really launch coronal mass ejections out, especially big, powerful ones. This was a quick blip up and then back down. Still strong enough though to launch a coronal mass ejection out towards the SWAN comet. How that's going to interact with that is the big unknown. And just to show you the more zoomed out light curve for the SWAN comet, here it is. You'll notice that when it's far away from the sun, it's very, very dim, but when it's near its perihelion, it gets quite bright. So that perihelion is already passed as September 12th, but now we see that's actually defined this trend. And look at how it was following that expected curve pretty closely, and then boom, went up. That's that outburst. Now that could go back down, right? It's an outburst. Often they have an outburst and then they just resume normal activity. Or they'll have multiple outbursts, things like that. Or they'll have an outburst and then the comet is actually disintegrating and does not survive that much further out because the pressure of it getting so close to the sun caused it to collapse. Bigger comets are less likely to do that. This comet seems to be quite large because it has this tail behind it greater than 2.5 degrees. So clearly it has a lot of material and gas and dust and plasma to eject out behind it, and now it has this outburst. It's sustaining that outburst for more than 2 days now, and that may continue. It may defy this expected light curve, and that will have to get recomputed to actually account for its actual brightness. And if it's expected to get brighter and brighter into October, which is the case already, then this should be visible to the naked eye in October, especially around like mid-October or again October 21st when it's closest to the Earth. And that angle that it will reach on October 21st is not that far off from the angle that the Earth and the Sun has. So if we continue to get more solar flares and solar storms launched, perhaps because of this comet and or the others, then we could be in for quite a shakeup this October in terms of solar activity. And we can add one more layer into all of this, which is that this 6.4 M-class flare, the strongest that we've had in months, does come just days after those two nova explosions in our night sky. That was V7994 Sagittarii and then also V1935 Centauri. And well, what is a nova explosion? It's a big outburst of light and energy from a star or a binary star system. And we received a lot of X-ray light and also a lot of gamma rays from those nova explosions. Those were picked up by our detectors. And so the solar system got hit with a wave of extremely high intensity, highly vibrational light. Then we see this outburst from the comet. We see the strongest solar flare from the sun. And it really just goes to show you how everything's connected, not only here on Earth, and not only here in the inner solar system, but even to the edges of outer space, how these sort of celestial events can trigger changes here on Earth. And well, that is why I am so interested in Interstellar Object 3I Atlas, because we don't know where it's come from. We don't know what it is. We don't know its history. We know that even like molecules that are critical to life, even like DNA, amino acids, all those can be created and maintained in space. It's a big unknown, and then we get this crazy planetary geometry to line up on the 21st of October with that object. So I will keep you up to date every step of the way. Thanks again for watching. I've been your host, Stefan Burns. If you want to stay up to date on what is happening with the Earth, the sun, the cosmos, and more, then this is the channel. We go into earthquakes, volcanoes, and what's happening geophysically with the planet, also weather and more, solar activity, space weather, planetary resonances, planetary geometry, and these sort of celestial events. Bring that all together and add in a dash of consciousness. So hope to see you around. We're on the road to 500K. We're about to blast past that. Make sure you subscribe before we zoom past that target. And then we're on the road to 1 million. Whoa. And if you'd like to get some merch, we have that available at earthevolution.com/store. The Boom Shakalaka t-shirt is a bestseller. Boom Shakalaka. And also the Interstellar 3i Atlas shirt has been very popular as well. New merch coming in just a few days. Super excited to drop the latest merch. You guys are going to love it. It is awesome. So thank you all so much. Wishing each and every single one of you well. Please make sure you ground yourselves, treat yourselves well, drink good water, eat clean food, breathe good air, go outside in nature, take time to relax, meditate, and just decharge. And I'll see you all in the next video.